We'll wait for a couple of more minutes and let me just enable the attendance. Okay. Yeah, it's enabled now. So is this the first class of the day, or you guys are already having some class? Okay, we'll wait for a couple more minutes. Was planning to start when there are 50 people. I guess it's a bit too much. Anyhow, so we'll start. Let me share the screen. Okay. How many? 46. Okay, let's start. Okay, so we have already covered one major concept of object-oriented programming, that is inheritance. And you already know what exactly does it mean when I say class A is derived from class B, right? So whenever I say this, what exactly does it mean? I think you are already aware of that. So now the next most important concept of uh, object-oriented programming is polymorphism. Okay, so now first of all, what exactly is this term polymorphism? So this term, you know that in computer science there are so many terms that we actually borrow from other fields. Okay, so for example, bridge is a term that comes from the construction industry, right? I mean, bridges are built in the construction industry, right? And we say whenever there are, like, let us say, two devices which are supposed to be connected to each other, we put a bridge. Similarly, architecture, right? Architecture is a word that has come from, as the field suggests. Okay, the architects, okay, they have basically lent us this term. So pretty much all the terms that we have, inheritance, right? Inheritance comes from the fact that you inherit something from someone, so that same term is there. So similarly, there is another term called polymorphism. Okay, and this term actually comes from biology. Okay, so we are also borrowing some stuff from biology. So what exactly is polymorphism? So this is just a simple definition that it says that polymorphism is the occurrence of two or more clearly different morphs or forms, also referred to as alternative whatever whatever, to be classified as such. Morphs must occupy the same habitat at the same time and belong to a something like that, right? So basically this is the idea that these two are actually morphs. Okay, they are two different types of jaguars, and this is known as, in the real world, this phenomenon is known as polymorphism. So if you try to just sum it up, the idea is that there is the same species, relatively similar species, but it occurs in, let us say, multiple forms. That is the overall idea of polymorphism that biology has. Okay, so now what exactly is this term doing in object oriented programming? So we have already discussed inheritance, as I said, right? So inheritance means there is a particular class which is deriving from one or more classes. Okay, so now that you know already what is multiple inheritance, you know that there can be more than one base classes also for a given class. So what exactly is polymorphism in terms of object-oriented programming? The I mean, there are three things to which are collectively called as polymorphism. So the first aspect, and this is what we will cover today. The next two are for the next two lectures. This is, let us say you have two pointers. Okay, so I'm not talking about objects themselves. Actually, this there is a problem with the terminology. If for example we were in the Java realm, okay, in Java there are no pointers, by the way, right? So basically only thing that is there are objects. Okay, but essentially these objects are nothing more than pointers. They are in some ways references to some memory location. Okay, so in Java we simply call them as objects, and in most object oriented terminology, that object oriented languages, the terminology is the same, right? You basically call them objects. But in C and C++, you can see these pointers explicitly. Okay, the pointers are available for your use explicitly. So basically, let us say you have two different objects, but the kind of pointer that you are going to use to point to them is exactly the same. I'll tell you when and how this can be possible, but this is the idea that if you have two pointers, where I'm simply calling them object references, these are basically pointers of the same type, but they behave differently when used in the same fashion. This is one form of polymorphism. We will see an example for this in today's lecture. There are two other forms which we have to some extent already discussed. It is the same method behaving differently when used with different parameter lists, and the same method behaving differently when used with the same parameter list. And you can see that I even forgot to remove Java from here. So these are the slides that I borrowed from my Java lectures. I have of course now changed the examples to C++ examples, but so basically this is C++. I have given some C++ code that you can see, but the reason maybe Java is a better language to study these phenomenon is because you don't because in C++ you have this explicit concept of object and pointer to an object, right? In Java they are basically the same. Okay, there is really no concept of a pointer. Every object is essentially a pointer. So anyhow, I'll just change this to C++ because in this course we are only studying C++. So there is really no specific term for this first variation of polymorphism. People simply call it polymorphism. I really don't know if there is a specific term for it, and that is why I have written this. When I taught this to your seniors, I don't think anyone came up with any answers for it. So, but still, if you find out an answer for this type of variation, please tell me what is it called. I don't really know. The second type, this one, is known as method overloading. Okay, now this is the term overloading. Okay, and this basically is there in almost all object oriented programming languages, right? So and in fact there is a variation of method overloading called operator overloading. So C++ also supports operator overloading. So we'll have a look at operator overloading as well, but the term that we generally use is method overloading, or in general just the overloading. So overloading refers to a case where you have the same function or basically the same operator, and there are different arguments to this function, and then you have like multiple variants. So it's something like this. Let's say I have a method called func, right? And now I have one version of the func where it takes a single integer as input. Okay, so func int, that is how its prototype looks like. Then I create another function called func float. Okay, so now the name of the function is exactly the same. What differs is the parameter list. So if you need in your code to provide the same or similar behavior for different data types, okay, this is where overloading is often used. Okay, so overloading, the examples of overloading we will have a look at in the next lecture, but this is the overall concept of what overloading is. You basically have the same function and it has been defined multiple times. Every time the parameter list changes. The third type is where the parameter list also remains the same. Okay, so now this is going to be a problem, right? So this, and we have already seen this. This is known as overriding. So what happens is you only provide one definition in one class, but in the inheritance hierarchy, it is possible that there are different definitions available for the same method, right? So let us say if this method is being in fact it has to come from your base class, only then will we call it overriding. So let us say there is an inheritance hierarchy, and in this inheritance hierarchy a particular method is defined multiple times. Okay, let us say in class A, then class B derives from class A, you define it again in class B, then class C derives from class B, so you define it again in class C, so on and so forth. So this type of scenario is known as overriding. We have been seeing examples of overriding already. So now in this week we will have a formal look at what overriding is. So now, before we move to seeing actual examples, one of the things that you should go back and revise is this pointer to member operator. Okay, this is how this member looks like. We used this pointer to member operator with structure variables in the previous semester, if you remember, right? So if you wanted to access a particular member of a structure and you had a pointer to that structure variable, then you don't have to do amp, at the rate pointer and then dot the member. You can simply say pointer and this arrow and the member. That is, these two used to be equivalent. So if you have forgotten how the pointer to member operator works, just go back and have a look at it. Now the same operator is there in C++ as well. Of course, in C++ you also have classes alongside structures. So with the help of this operator, not only can you actually access those fields, you can also invoke methods on a particular object. That is the difference now, right? With structures, you only had member variables. With objects, you have variables, the fields, as well as the methods. So you can invoke both of them using this pointer to member operator. And you will see that wherever you will need some kind of polymorphic code, instead of passing an object, we usually pass a pointer to an object, and we make use of these polymorphic features of the language. I'll just show you a simple example in code right now, but that is the idea. Please go back and revise this operator if you have forgotten what it was and how it is used. Remember that the actual access rules are still applicable, right? So exactly where are you trying to access a member, that is still the same, right? I mean, if it is private, it cannot be accessed outside. If it is protected, it cannot be accessed outside, with the exception of derived classes. So all those rules still apply. It's just that instead of object dot member, you can also now write object ptr pointer member. That is the only difference. And there is a special type of pointer that is implicitly available to all the member functions, all the methods of a class, and this is known as the this pointer. Okay, usually in C++, the utility of this pointer is not really that high, but yeah, there is at least one particular use case where this pointer can be helpful. You can just go and check your homework, that is your homework, to figure out one good use case where this pointer can be useful. By the way, in most cases you can do your job without even knowing that there is something like this pointer. But for one particular use case, if you want to write your code that way, this pointer can be helpful. So one aspect of pointers when it comes to inheritance is that the pointer of let us say a class A can also point to objects of class B, provided that class A and class B are compatible with each other. So what exactly do we mean by compatible? That we will have a look. But the idea is I create a pointer of type class A, so something like A asterisk ptr, and then this ptr can be assigned addresses of objects of type not only A but some other types as well. Those types must be compatible with A. And when I say basically compatible, the word really is um, a particular type as well as all its derived types. So let us say if B is a derived class of A, then you can create an object of B and point to it using the pointer A. That is the only compatibility thing that we are talking about. So this is the piece of code that you should have a look at very with all the concentration and try to understand what is happening. If you're not able to understand this code, I'll go over this multiple times because this is a very important concept. So please pay attention right now and try to understand what exactly is this. uh where is the last one, huh? So I'm okay. Again, this new thing is wrong because now again there are some pieces of code that is coming from Java. Let me in fact edit it here itself so that there is no confusion. um, so let us see it like this. So I have two objects. Okay, one is of type st, one is a super type, and the other one is a derived type. So derived type is essentially inheriting from super type. Okay, so derived class is known as derived type here, and the super class is known as super type here. Now I create two objects, st and dt. Okay, I have these two objects. Now this is a pointer, super type pointer. Okay, so what it can do, it can certainly store the address of st. Why? Because st is a, so there is these are similar types. You remember, for pointers all you need is something like this. If it is int asterisk ptr, you can store ampersand I, where I is an int, right? The same thing is here, that st's type is super type. So super type asterisk is a pointer to super type, and it can store access to it can store the address to st, right? Now this is not required, okay, because I don't need pointers in C++. So now this is the third pointer. This is second pointer, ptr2. This is also straightforward. Both classes are of exactly the same type. So dt here, its address can be assigned to ptr2 easily, no issues, right? And I think there is no confusion till here. This is simple pointer arithmetic, that there is one ptr1 and this ptr1 is of type s super type. This ptr2 is of type derived type, and they are just storing addresses to objects which are of exactly the same types. That is the idea. This is something that is new. Okay, so this super type pointer ptr3 can also store address of this particular object, derived type. Can anyone guess why is it possible? How is it possible? Any wild guesses that why am I able to store the address to a derived type object using a base type object? Any wild guesses? Why would it be possible? It is something similar on the lines of specialization and generalization. Okay, so let me give the answer. Basically, the idea is something like this. Let us go back to our pizza examples. So if I have a pointer which says I can point to a pizza, right? It can certainly point to an onion and tomato pizza or a paneer and capsicum pizza. Right? Because onion and tomato and paneer and capsicum are also a specific type of pizza, right? It's just that this pointer does not have enough knowledge to know that this one is onion and tomato and this one is paneer and capsicum. For it, both are just pizzas. Does it make sense now? That basically what happens is, whenever you have a pointer to a super type, you can always point to an object of the derived type. Why? Because the derived type is just a specialization of the super type. Whatever is there in the super type, all the fields of the super type are also there in the derived type. You remember, right, that even when private members are not inherited, you still have to create space for them, right? Why? Because the constructors are called in that order. The base class constructor is called first, and then the derived class constructor is called. So all the fields, whether they are private or protected or public of the base class are essentially available within the derived class object. It is just that the derived class might not have access to it, but they are still there. Okay, so this piece of code, up to this point, if anyone has any doubts, please ask right now. This is one of the most important concepts of object oriented programming. And if you actually move to Java, which is, I think, in the next semester you may have Java, so this will be your bread and butter. Okay, these type of assignments will be very common in Java. So at least you should know the concept, that why is it that super type is able to point to derived type. And by the way, the other way around is not possible. If you try to create a pointer of the derived type and try to point a super type object, that will give you an error. Okay, the other way around is not possible. It's only a one-way street. So if you guys have any doubts up to this point, please ask anything that is coming to your mind, because this is a very important concept. Is it clear? Is it clear why this is possible? Because what are the member variables that you will try to access with the arrow operator for ptr3? It will be those members which are a part of the super type, not the ones which are part of the derived type. So as I said, all those members which were there in super type object will also be there in the derived type object. Is it too confusing? Should I go over it again, or
Yes,
is
sir.
it clear?
Can you go over it again?
Okay, so let us think about it. Okay, let's go back to our uh, toy example. Okay, so in the toy class, I think I only had 2 or 3 fields. There was an ID, there was a name, and there was a price. Okay, there were only 3 attributes of a particular toy. And then I say there a specific type of toy is battery operated toys. So in that, I think in that class I added a couple or maybe more properties. I said, okay, so battery operated toys, for battery operated toys you'll also have to tell me what is the battery type, how many batteries do I need, whether the batteries are already plugged in or not. So there were some other pieces of information that I needed to store. So now let's come back to the world of pointers. So let us say I have 2 objects. One is of type toy, and there is another object which is of type battery operated toy. Okay, let us call them T1 and T2. Now, if I create a pointer of type toy, and what will I do with this pointer? I will try to access the members of the class toy, right? So I will do things like t1 arrow name, t1 arrow id, t1 arrow price, right? So basically I'm assuming that this object, the object that I am pointing to, has these fields somewhere in the memory. Now for the battery operated toy, that is this T2 object, these fields are also there, right? I mean, this is what we saw during during the study of constructors, that whenever you make a call to the constructor of a derived type, the first thing that happens is it delegates the call to its superclass, the class from which it has derived. So the superclass object is created first, and then the derived class object is created, right? So in the superclass constructor, basically all the space that is required to store, for example, id, name, and price, that is allocated. So any object of type battery operated toy is guaranteed to have all the properties that toy has. The other way around, it is not guaranteed. Okay, a toy object is not guaranteed to have the fields from battery operated toy. Okay, it is the super class, and battery operated toy is the derived class. So that is the thing, that in this whole hierarchy, any base class pointer is guaranteed to be able to access a field, a property, a behavior which was defined in the superclass. Okay, but not the other way around. If you create a pointer to the derived type and try to access using the arrow operator something which is not a part of the super type, then there is going to be a problem. Does it make sense now? Basically, it is about hierarchy. That when you create a class from another class by inheriting another class, everything from that another class is also a part of your class. Plus, you add something more. So, if you want a pointer which is pointing to this something more, okay, it can the actual space in the memory must be allocated for this. Okay, and this is only possible if the object that you created is of the new type and not the older type. Whereas if you create a pointer to the older type, you are still guaranteed to have all the fields that were there in the older type, because when you inherited it in the new type, these fields will be a part of the new type. Does it make sense? If it doesn't make sense, what I'll do is I can probably send some pictures to you guys over email, where I can show you this is the super class object, and then over this I think I tried to show it using some text editor in some of the class. But that is the idea, that let us say the super class had three fields. So now when you create a derived class, those three plus let us say two more fields get added to the object. Now you derive it again into a third class, so then 2 plus 3, 3 plus 2 plus let us say one more field gets added in the third class. So now you have six fields. So the object size keeps on increasing as you
So,
move down. Yeah, go ahead.
uh, the member variables which are part of derived class and not superclass, would they also be accessible?
No, they are not visible, but you still allocate memory for them. So a typical example I gave was something like this. Let us say there is a member in the superclass which is private. So certainly it is not inherited, right? Inherited as in the derived class does not have access to it. But assume that there is a method in the superclass, something like get id and set id. Even though id, the variable, the field is private, you can still have two public methods, okay, get id and set id. So these public methods are inherited by the derived class, and these methods are, they are still valid. You can still call derived object dot get id, derived object dot set id. So if you call these methods, and assuming that they are simply, these two methods are simply returning and setting the value for field id, it means that id has to be present somewhere in the memory. Okay, even though the derived class cannot directly access it, the idea is you give it access via these public methods, the getter and setter methods. If you remember from the first class, that this is the standard way to provide access to private members of a class. You create two methods, get x and set x. Okay, and then in the set x method you can write whatever validation code you want. Okay, so you see what values are valid and what values are not valid. If I had access to the private member, I can simply do um, object dot x equal to 5. Okay, but if I am forced to use object dot set x and then give 5 as a parameter, I can write some validation code within the set x method. That was the idea that we had. So yeah, so
Sir,
that, go ahead.
sir, can you give any example where this super type a pointer can be preferred over derived type pointer?
Super type pointer will be preferred over derived type pointer. That is what you are asking.
Sir,
So
some example. Yes, sir.
okay, I'll show you the example. Don't worry. We have the example just coming up. Um, but can you understand this code? That is the current question that I have. That do you guys understand what this code is and why this works but this doesn't work? If you are able to understand this, I'll certainly take you to the examples. But if you have any questions at this point of time, I'll tell you what is a use case. When exactly will you need to point to an object of derived type using a pointer of base type? That I will show you an example. But do you understand the concept? What exactly is happening here? If you understand this, we'll move forward. And by the way, uh, this the idea that you are able to point to a particular member a particular object of type derived type via base type, it doesn't matter that all those access specifiers become null, right? So for example, you cannot do this. Okay, ptr3 is here, right? So this, okay, this is this ptr, sometimes it just capitalizes things on its own. So this ptr3 here, ptr3 is of type super type. If you try to do this method added in derived type, okay, this doesn't work. Okay, because here you will the and the other way around also it doesn't work. So if you try to do, for example, uh, so let us say if you have ptr1, ptr2 here, and you try to access a uh, so you try to access something which is only accessible to the base class, it won't work. That is better. So the idea is that all the access specifier, all the access control still works. This is an example that if you try to access a method that was added in the derived class using a pointer to a base class, this will not work, because to the base class pointer it is blind. It simply does not see that this method has been added in the derived class. Anyhow, it is a bit confusing. I'll just move to the example straight away, but up to this point, if you guys have any questions, please ask me. Otherwise, I'll just show you the use case where this kind of thing is useful. Okay,
Sir,
I'll, yeah, go ahead.
can we think this of like a super type as long and derived type as int?
So super type is, yeah, yeah, in some ways it is right. In some ways it is right that long and int kind of thing, that a long is also, an int is also a kind of long, right? I mean, everything that is an int is also a long, but not the other way around. Yeah, so that is a good analogy, I would say. So what I'll do is I'll first show you the example, and I'll come back to this slide because I want you guys to be very clear with these concepts. So let us first look at an example. Why, in which particular case can this be useful? So going back to our toy example, let us say now I want to have a function where I am basically going to put a particular toy on sale. Okay, so let us say this is a function which is working as part of some online toy selling website. So here now what I'm trying to do is I'm just putting a particular toy on sale, and the way I do it is something like this: putting this toy, the name of the toy, for sale. I give it a specific id. Id is something similar to your product id or barcode, whatever you have on products. It has to be unique for a particular product, for a particular instance of a product, right? So if there are two aeroplane toys, they'll both have different barcodes. That is what I was trying to say. And so this is what this method simply does: putting this particular toy for sale with this particular id for the price of this. This is the price. That is it. So here you can see that all that this particular method requires are the fields from the toy class. Okay, it needs the name of the toy, the id of the toy, and the price of the toy. It doesn't need to know whether it is a battery operated toy or not, whether it is a flying toy or not. This method just wants the name, the price, and the id. Only three things of this object are required. It doesn't need anything else, right? So what one way to do this is that I create the parameter here. What should be the parameter of this uh, what should be the type of the parameter of toy on sale? Okay, so one way to do it is that for each class that you have in the class, in your domain, you do function overloading, method overloading, and you put as many functions of that type as possible, right? So you have one for battery operated toy, one for flying toy, one for plane toy. So you create different versions of this. Otherwise what you can do is you can create a pointer of type toy, and now this is what where the magic comes, right? So basically this is what we are going to do now. This is straightforward. I created a pointer of type toy, and I created a new toy, let's say blocks, and then I passed it to put toy on sale. This is straightforward. The pointer as well as the object, they are of the same type. But here is what is the advantage of polymorphism. I created an instance of battery operated toy, and then I pointed to it using the same toy pointer, and now I passed it on to put toy on sale. Similarly, I created instances of flying toy and plain toy, pointed to it using the toy PTR pointer, and passed it to the put toy on sale function. Okay, and this is the beauty in some ways of my this is the homework, right? Yeah. So this is the beauty of how polymorphism can help you, right? There is no problem. All this code is absolutely legal. You'll have no problems. Why? Because the only thing that put toy on sale requires are these three fields, right? Get ID, the name, ID, and price. And all these objects, battery operated toy, flying toy, plain toy, all the objects of these types, they all have these three fields. They might not be accessible because they are private, but they are still there. And because this get name, get price, and get ID, these methods are public, they are guaranteed to be a part of all these three. Okay, I mean, there is a particular situation where you it's not really guaranteed. You can still inherit them in the private section, and in which case this will this will throw an error at the runtime. At the compile time, there should, I don't think there might be an error. Sometimes the compiler also detects it at compile time, but at the runtime there may be an error. But as I said, it's the access specifiers are still valid. It's not like you can violate access control. But as long as the access control is perfect, there is no problem with it. This is an absolutely legal piece of thing to do. Okay, you create a pointer of the base class, and then you create objects of derived classes, you assign addresses to them, and then you can use it like a base class object. That is the idea. Okay, now questions. We'll go back to that slide again now after this, but any questions on this? You understand why did I do that? Here I knew that there is a particular behavior for which I really don't care, what derived type of toy is it, right? As long as it is a toy, I only need the name, the price, and the ID. Okay, I don't care whether it is a derived type of toy. It could be battery operated toy, it could be plain toy, flying toy, any toy, right? As long as it is a toy, the only behavior that I want, the only properties that I want to access are available, and so I can catch these parameters using the pointer to the base type. Okay, so this is a very convenient way. In fact, in Java, this is, as I said, these things are all bread and butter. When you create, when you start looking at APIs in Java, this is used so heavily that at so many places the expected parameter of a function will be of a base type, whereas what you will be passing to it will be of a derived type, but it will work like a charm. Why? Because the only properties that that particular function expects from the object are from the base type. So it doesn't even need to know whether you are using the base or the derived type. Can you understand this use case? Where can it be useful? This can be useful where you have a class hierarchy. There is a particular function, a method, where the only properties or behavior that you require are from a base, a higher class in the hierarchy, a base class. Okay, so then if you make the type of your parameters as the base type pointers, you can always access everything that is below that hierarchy. All the classes which are subclasses, derived classes of this particular class, can then be handled in this function without writing multiple instances of the same function. As someone just suggested, it is like saying, if there is a possibility that the number for which you are going to work, for the number that could be passed to a particular function could either be int or long, then what is the type that you create? You create long, right? If you create a parameter of type long, you can always pass an int to it, you can always pass a short to it, you can always pass a char to it, right? but long means anything that is long, okay? And it could be int, it could be char, it could be anything. It could be short, it could be byte or whatever it is, right? So is this part clear, that as long as the requirements for your code is only up to a base class level, it is perfectly fine to create a pointer to the base class and then keep on passing object references to derived types. Okay. Shall we go back to that slide again? Let me go back. Yeah. So now, do you guys understand what is this? Is there we are now revisiting this again. Okay. So do you understand this slide much better now? Any questions now in your mind? I'm putting so much time on this because this is a very important concept of object-oriented programming. It is not only here in C++. Almost all the object-oriented programming languages that you will use, this same concept is used there as well. Java, C Sharp, I think Python. If you are using object-oriented programming in Python, then all these languages will have the exact same concept. Many a times there will be a super type, and you will keep on passing derived types to it. Okay, so please grasp this concept clearly. That is the only thing I want you to. In fact, this is why I am discussing it separately. I thought there will be so many questions, but there are none. I thought this will be extremely confusing for people, um, but it looks like it's clear, or it's so confusing that you don't even have a question. Is it? Okay. Um, so so this is it. I mean, for this lecture was only up to here. If you guys have no questions, we are done really. But I just want this part to go through. That is the idea. And sorry for the goof ups in the slides. Actually, I started preparing the slides very late. You know, no, right? This week was so hectic. We had these project presentations, and even till yesterday I had to take some extra class. So I started it very late. Then I realized, okay, I've already taught polymorphism to your seniors in the Java class. So I borrowed certain slides from there, and then I wrote this C++ example. So yeah, some of the copy pasting did not work as expected. So yeah, that is my bad. I'll change these slides properly and put it on Google Drive. But concept wise, this slide basically sums up everything that we wanted to discuss. So if you have any questions, please ask. Otherwise, we are done. So fun. Yeah, Pranav, I really don't know what is the best term, right? I mean, this is just some ad hoc terminology that I used. I really don't know. So it is much easier in Java and other languages like C Sharp, where these pointers are they are really not explicitly used. They are used in the background. But with C and C++, you have to explicitly differentiate between object and pointer to an object, okay, because you have access to both. In Java you just have access to one, right? I mean, it's just the object and it's a pointer. So even I was really not sure what is the right term here. Polymorphic pointers, polymorphic objects. The first name I used was polymorphic objects, but then I realized it might be confusing because it's not really the same object. These two objects are actually of different types. It's just that the reference to this object, it is of the same type. So that is why I thought polymorphic references, polymorphic pointers. Um, the terminology, I really don't know what is the best terminology to use. I just wanted the concept to get through. Yes, that I know, but I did not want to go at the level of compile time and runtime binding. That is why, because that is like starting, opening another Pandora's box of trouble. Because compile time and runtime binding, that is actually a much more larger concept. Okay, so you should be able to understand how linking works, for example, in order to know, and how memory allocation works when a program is loaded by the loader. So I did not go in that direction because it is going to be difficult for many people to understand the difference between compile time binding and runtime binding. Okay, so yes, any questions on this? I know this course is not really going the way I planned it. Maybe if we had these labs, probably you will be uh, much more up. You'll be able to keep up with the concepts, because till now we've only had concepts. There are really no labs. So let us hope this week's lab brings you forward a little bit. Okay, so when you try to write code for all these things, you actually figure out that there is something related to the concepts that you've studied in the class. So I think one batch will have a lab tomorrow, right? And the other batch will have lab on Wednesday, I guess. So I have talked to the TAs. Looks like all TAs are fine. I haven't received any message from a TA saying that I'm not well. So looks like all your TAs are fine. So on your respective slots of lab, it will be a practice lab. So it's not going to be evaluated. I'll just give you some problem and sit with your TAs for 2 hours and try to write some code for it. If you get stuck, ask your TAs, they'll help you out. Okay, so let us hope that all these concepts that you've been studying all this while, when you start writing code and when you start applying them in C++, um, it works out. Okay, and remember, by Friday you have to, I didn't check how many people have added the projects, but by Friday you are supposed to create your groups and select a project title. Okay, and then send me an email with your projects, uh, one paragraph summary. What exactly is it that your project is about? Okay, any other questions? Okay, guys, thank you. Bye.